use either in counter mode or timer mode. So that I mentioned. So everything is just a registers, just you are going to use either as a timer or counter. In counter mode, the counter register is incremented for every external event, that is the clock signal. So because the clock signal is synchronizing the counting between the registers. So now rising edge or falling edge or both, you can choose or you can select whatever the clock edge you want. So the counter period is here, of course here, because the counter period is not fixed. So it uses asynchronous mode of operation. Counter is using asynchronous mode of operation, but the timer is using synchronous mode of operation. Okay, so just try to remember this point. This is the difference between counter and the timer. The counter can count asynchronously, but the timer must need synchronous counting. So the register value will increase. So let's say R4, R3, R2, R1. So you have set up the first bit values 0, 0, 0, 0. And if you use this as a counter, here is the counter. So here we do not really need to make the synchronization, but this counting is just based on the clock signal edges. This is kind of synchronizing, but we call this an asynchronous mode of counting. But the timer, for example, if this timer is, let us say RCC, real-time clock signal, or real-time crystal clock. So it means, for example, in your microwave oven or your washing machine, so you also have the kind of the real time, it will show the real time. For example, now the time is like at 9:45 a.m. So you can see that. So the timer needs to be synchronized. So you set the alarm clock in your mobile phone to wake up in the morning. So the timer must be synchronized with the real time clock. Then only you will get the right time, the alarm signal. So that is why the timer is always in the synchronous mode, but counter can work in the asynchronous mode, even though we use the rising edge or falling edge. So that is the difference between counter and timer. Okay, so the clock speed of the L476 is 80 megahertz, but even though in the example we get seen 72 megahertz, that is the another microcontroller F103. So you try to go to the data sheet. STM32L476 microcontroller has several timers. We will use 16-bit timer in our example today. It means 16-bit means, so it can count up to this many levels. So 2 to the power 16 is equal to this number. So here, in order to do this experiment by yourself, you do not need any additional hardware. You just connect your microcontroller to your PC, that's all. And you can configure the port and so on, and you can test the timer, how it works. For additional information, please try to open the data sheet of this microcontroller, and you can get some more information about this data sheet and its timers. So now I think we will go to the next page. Of course, you can find also some more information about the watchdog timers and so on. So here is the the data sheet of the L476. So here you can see how many timers we have. This one is having. So for example, this timer 1 and timer 8, it's used for advanced control, and the timer 2 and 5 is used for general purpose, and 3 and 4 and so on. So here you can find out everything. But in this example, as I mentioned, we are going to use timer 16. It means 16-bit timer we are going to use. This is mainly used for general purpose. You can see the timer type, it's a general purpose. It's not the basic or it's not the advanced one. Okay, so this microcontroller also have some special purpose timers other than general purpose, that is used for SysTick delay functions. Yes. So other than the general purpose, we have some more different types of timers. So this is used for different purposes. So this is the clock tree diagram. So that is also you can find in datasheet. So clock tree diagram is very useful to figure out how these timers and clock signals are connected internally. So each timer has its own individual prescaler. For example, here I mentioned like a 16-bit counter we are going to use. 16-bit is here. So 16-bit, for example, so this 16-bit counter is, you can see it has its own prescaler value. So this is it's connected to AHB bus. So we know there are two different types of bus, AHB and APB. The APB has two types, APB1 and APB2. So this 16-bit timer is connected to its own prescaler value. What it means? So it means you can set up this prescaler value and you can change or you can slow down the system, the clock period. So that is what we get seen in this example. So you can set up the prescaler value to any value, whatever you want. So based on that, you are making up this internal clock, number of internal clocks. So then the counting will be according to the prescaler value you set up. And also I mentioned here, the main purpose of the prescaler is to slow down the timer clock frequency. So that you can set up here. If you open your Cube IDE, you can see here, if you go to the clock configuration, either you use the Cube IDE or Cube MX, it's not a matter. You will see, if you open the clock configuration tab, you will see this prescaler possibility where you can type and you can change the value by yourself. Okay, so and also reference manual. If you want to dig more detail of the timers, you can go to the reference manual and it has more detail about each timer. So you can see that and you can see all of the registers that needed to control timer. But it will be good for you to know that the timer's counter value at any given moment can be found by reading the timer's count register. So the timer is counting, for example, let us say 4-bit, it's counting, maybe it's somewhere in the middle, maybe it's here in this bit. So what is this decimal value? 8421, right? So this is 4 equal to decimal number 4. So I suddenly want to read the register's value, whatever the value is in the register, I want to read and know that in the display. So I can do that. So I don't need to wait until the counter to be finish the counting and then overflow or underflow. So that is possible. I can track the counter value at any given moment. Yeah, if you read more, then you will understand more about this as well. But this is not really about this datasheet, but this is just like a general uh, uh, purpose of the timer, how the timer is working, and you can read the timer value at any time just by reading the registers values. So here you can see here now, and this example is just talking about the STM32F103. So now we are setting up, for example, you can set up first this system debug mode and then the RCC and then the timer. So for example, in the timer, you can see like whatever the mode you can enable, disable, and because each timer has many channels, so you can do whatever you want. So now we are setting up the clock source as the internal clock source. So here you can see I am setting up I am taking only channel 1. In the channel 1, I am enabling the internal clock. And then I can go here. So once I set up this output pin TB6 for the LED. So it means like the pin number 6 is connected to the LED as a GPIO output. And then you go to the clock configuration mode, and then the clock configuration tab, you can see here the prescaler value where you can change the prescaler value, HB, and also APB1. You have the prescaler value where you can change. And here is the maximum clock speed, that is the 72 megahertz for this microcontroller. This also you can change, but here for this example you can keep this as the maximum value, that is the 72. And then you go to the configuration tab, and then the configuration tab you go to the GPIO. In the GPIO you set up only one pin PB6, that is for the LED, red LED, and this is in under push-pull mode. We had seen about push-pull mode or open drain mode last week. So this is under the push-pull mode. And also here you can set up the user label. And then now you can click the timer, and then the timer, what we are doing now. So here you can see this prescaler. We can also change the prescaler value here under the timer. And under the timer, now we are under this parameter setting. So you can set up this prescaler value. Now this is in the maximum value. Under the counter period, it's a 16 bits. So we are making this 100,000 to 1 scale. And this is in the up counting mode. So you can see here the prescaler value we set as a 7,200. So we know the formula. So that is n divided by the maximum clock speed. So here like a 72 megahertz divided by 7,200. So that is kind of 10 kilohertz. So now we are in this NVIC settings. NVIC settings, we know what is this for. This is to set up the priority to interrupts. So here you can set up this timer 1 update interrupt, that is we are enabling this one. So now you can generate the code. It's very simple now. So for example, after you finish all these settings, then you can just go here and then you can set up the you can generate the C code, and then you can edit the C code.